Rectifier is an electrical device which converts an alternating current into a direct current by allowing a current to flow through it in one direction only. The process of converting AC to DC is called as rectification. Diodes are used for rectification. A PN junction diode allows electric current in only forward bias condition and blocks electric current in reverse bias condition. In simple words, a diode allows electric current to flow in one direction. When an AC passes through the diode only allows positive half cycle to pass through it and convert this positive half cycle into DC. While the diode removes the negative half cycle coming from AC, it means diode only operates in forward bias condition. Now you can see from the picture as shown below. The DC current produced by a half-wave rectifier is not a pure DC current, it is a pulsating DC current. From figure you can observe diode removes the negative half cycle and allows the positive half cycle to pass through it. This is the characteristics of half-wave rectifiers. Types of rectifier. We are using rectifiers for single phase and three phase supply. Rectifier can be uncontrolled, partially controlled or fully controlled. In single phase we have half wave and full phase rectifiers which we can not control. In single phase full wave rectifier is further classified as split supply and bridge rectifiers. In three-phase supply, we have half-wave and full-wave bridge rectifiers that can control or cannot be controlled. It depends on the requirements. Types of rectifiers. There are two types of rectifier in single-phase supply. Half-wave rectifier, full-wave rectifier. Half-wave rectifier is a type of rectifier which converts half of the AC input signal positive half cycle into pulsating DC output signal and the remaining half signal negative half cycle is blocked or lost. In half-wave rectifier circuit we use only a single diode. As the diode is an uncontrolled device, so half-wave rectification can't be controlled. Efficiency of half-wave rectifier is 40.6%. Ripple factor in half-wave rectifier is 1.21. Working of half-wave rectifier. When a sinusoidal waveform as an input is given to a circuit which have a diode in it as shown in figure, the diode have the characteristics to conduct in forward condition only and allows the positive half cycle to pass through it and removes the negative half cycle. So through this way we shall get only a positive half cycle at the output by half-wave rectifier. By this way we can say that half-wave rectifier allows only positive half cycle to pass through it. Application of half-wave rectifier. Half-wave rectifier is used in AM radios to rectify the signal. Half-wave rectifier is used as two-level lamp dimmer. Advantages of half-wave rectifier. Cost is very low, easy to construct. Disadvantages of half-wave rectifier. High power loss, pulsating direct current, not a pure DC, produces low output voltage. Full wave rectifier. The full wave rectifier is a type of rectifier which converts the full AC input signal, that is positive half cycle and negative half cycle, to pulsating DC output signal. It uses two diodes of which one conducts during one half cycle while the other conducts during the other half cycle of the applied AC voltage. The maximum efficiency of a full wave rectifier is 81.2%. During the positive half cycle of the input voltage, diode D1 becomes forward biased and D2 becomes reverse biased. Hence, D1 conducts and D2 remains off. During the negative half cycle of the input voltage, diode D1 becomes reverse biased and D2 becomes forward biased. Hence, D1 remains off and D2 conducts. Full wave rectification can be done by two ways: using bridge rectifier circuit, using center tapped transformer. Full wave bridge rectifier. Bridge rectifier circuit uses four diodes in a bridge configuration for its operation. It uses normal transformer and use a transformer is not mandatory in bridge rectifier. It is inexpensive as it doesn't require costly center tap transformer. Its ripple factor value is 0.482. How bridge rectifier works. When an input AC signal is applied across the bridge rectifier, then during the positive half cycle, diodes D1 and D3 are forward biased and allows electric current, while the diodes D2 and D4 are reverse biased and blocks electric current. While during the negative half cycle, diode D2 and D4 are forward biased and allows electric current, while diodes D1 and D3 are reverse biased and blocks electric current. The output of bridge rectifier is shown which shows that bridge rectifier converts negative half cycle input to positive half cycle output. Positive half cycle of bridge rectifier. As discussed previously, during the positive half cycle of full wave bridge rectifier, D1 and D2 are forward biased, so current will flow through these diodes and create a positive half cycle as shown in the figure. Negative half cycle of bridge rectifier. During the negative half cycle of full wave bridge rectifier, D1 and D2 are reverse biased, so they will act as an open circuit, while D3 and D4 are diode are forward biased and closed circuit, so current will flow through these diodes and creates a positive half cycle on the second half of sinusoidal wave output as shown in the figure. Center tapped full wave rectifier. A center tapped full wave rectifier is a type of rectifier which uses a center tap transformer and two diodes to convert the complete AC signal into DC signal. The center tapped full wave rectifier is made up of an AC source, a center tap transformer, two diodes, and a load resistor. The center tapped full wave rectifier is costly. Its ripple factor is 0.482. Center tap full wave rectifier. Positive half cycle. The center tap full wave rectifier uses a center tap transformer to convert the input AC voltage into output DC voltage. When input AC voltage is applied, the secondary winding of the center tap transformer divides this input AC voltage into two parts, positive and negative. During the positive half cycle of the input AC signal, D1 become positive, D2 become negative, and center tap is grounded 0 volts. So the diode D1 is forward biased during the positive half cycle and allows electric current to pass through it. Negative half cycle of center tap rectifier. During the negative half cycle of the input AC signal, D1 becomes reverse biased, D2 becomes forward biased, and center tap is grounded 0 volts. So the diode D1 is reverse biased during the negative half cycle and does not allow electric current to pass through it, due to which positive sinusoidal is produced during the negative half cycle. Advantages of full wave rectifier. High rectifier efficiency, low power loss, low ripples. Disadvantages of full wave rectifier: high cost.